Hi guys, and welcome back. So as we discussed in the previous video, the CoreDNS component is deployed onto your cluster as a config map, a deployment, a replica set, and a couple of pods here. And those pods get connected to your cluster network so that your different application pods and services can communicate with the CoreDNS pods. Now, the configuration of the CoreDNS component itself is, of course, done with the config map resource here. And so what we're going to do now is just kind of explore an existing cluster that I've already created using EKS CTL, which is an open source utility that allows you to provision a cluster on Amazon Elastic Kubernetes Service. However, you can use other types of Kubernetes distributions as well, or other cloud vendors. There's a lot of different cloud vendors out there that support Kubernetes as a managed service. So if you actually go out and just search for the autoscaler component, this is, I've got a separate training on this, but the cluster autoscaler is basically a mechanism that allows you to horizontally scale your cluster by adding more nodes to it. But what's nice about this project is that they actually have documentation that describes some of the different cloud vendors that are out there that provide managed Kubernetes services. So if you go under the autoscaler and then take a look at deployment down here, they actually have a list of supported cloud providers. And so these are a bunch of different cloud providers that expose managed Kubernetes service. A lot of the popular ones, of course, include like Google Kubernetes Engine or Amazon Web Services, the EKS. And we've also got Microsoft Azure Kubernetes Service, or AKS for short. And then there's a lot of smaller cloud vendors out there that are more specialized but provide a better user experience. And some of those are like DigitalOcean. They've got a really nice user interface. Their pricing is much more competitive than some of the major cloud vendors, and their APIs are just a lot easier to work with as well. Same thing for Linode as well as Vultr. Those are just really more niche focused cloud vendors, and they provide just an overall better user experience. But I'm just going to be using Amazon EKS here. And the utility that I'm using to provision my cluster here is, of course, EKS CTL. And this is actually developed by a company called Weaveworks that has some plugins for Kubernetes called like WeaveNet, for example, or WeaveScope. And they provide this open source utility, EKS CTL, specifically for the purpose of simplifying deployment of Kubernetes clusters on Amazon EKS specifically. So you want to use this utility if you're planning to use Google Kubernetes Engine or Azure Kubernetes Service or Linode, DigitalOcean, etc. But this just makes it really easy to create a cluster with a couple of simple commands. But I've already got a cluster up and running here, and I've got the kubectl command line utility attached to it. So if I do kubectl version, you can see that I am running Amazon Elastic Kubernetes EKS version 1.21.5. So EKS is a couple of minor versions behind on Kubernetes. The current version of Kubernetes is actually 1.23, and that's the client version that I am using right here. But I'm actually talking to a slightly older cluster version, which is the latest version that's available for EKS specifically. All right, so once you've got your cluster up and running and you've got your kubectl command line utility attached to that cluster, let's start to explore what CoreDNS looks like. And as we discussed before, the CoreDNS components are going to be provisioned into the kube system namespace here. So when we are looking for these different objects like the config map for CoreDNS and the deployment controller for CoreDNS, the replica set, and the actual pods themselves that are actually running the CoreDNS application, the binary, we are going to want to be exploring the kube system namespace here. And we can specify the -- namespace parameter on kubectl in order to specify that we want to explore resources that are in this namespace right here. So let's go ahead and run kubectl -- namespace, and we'll say kube - system. Actually, let's do this first. Let's do kubectl get namespace. You can also do NS for short if you don't want to type out namespace, but I like to type out the full resource name just as kind of a mental exercise to ensure that I kind of know what I'm doing. So NS is short for namespace if you like. But now what we can see is that we've got our kubectl node lease, kubectl public, kube system, and of course the default namespace where you can provision whatever applications that you'd like to in there. But kube system is kind of I don't want to say it's necessarily a special namespace, but it's a namespace that often contains the system components for Kubernetes. So if we say kubectl get all, and we'll add on the namespace kube-system parameter here. This is going to show us all the different resources, or at least most of the core types of resources that are in that namespace. And as you can see right here, we've got the deployment controller called CoreDNS, and the deployment controller has been configured to request 2 replicas of CoreDNS itself. So right here, you can see it's requested 2, and there's currently 2 available. Also remember that the deployment controller itself does not actually create the pods directly, but the CoreDNS deployment will create a replica set, and that replica set is then what actually creates the pod. So you want to be also looking at this replica set resource right down here, and the name of the replica set should match up with the deployment name here. And then after the deployment name, it'll actually have kind of a randomized string here, kind of just a partial hash value. And that is going to serve as just a unique identifier for that particular replica set. And if we were to make any changes to the CoreDNS deployment and then roll out those changes to it, then the deployment controller would actually create an entirely new replica set resource, and then it would spin down the 2 pods that were requested from this first replica set, and then it would create a new replica set that requests 2 pods, and it would kind of slowly switch from the old replica set to the new replica set. And then if we take a look right up here, these are the actual pods that belong to CoreDNS. And you can see, sure enough, there are 2 pods because that is what the replica set requested based on the deployment controller configuration. And then we have 2 in the ready state. So that indicates that CoreDNS is up and running. They're in the ready state and everything looks good here. So we can see that these pods are in the running state, and 1 out of 1 containers is running. Keep in mind that Kubernetes pods do support more than 1 container, so containers and pods do not have a one-to-one relationship. A pod can actually have more than 1 container. However, oftentimes you'll see a pod just have a single container in certain use cases. But for when you're building out enterprise applications and you've got complex application architectures, you'll often see situations where an application designer will define a pod as having more than one container inside of that pod definition. But as far as CoreDNS specifically is concerned, each pod for CoreDNS only has 1 container, and that container runs just CoreDNS, the binary. So if we wanted to kind of dive a bit deeper into this, we could grab the name of one of these pods, and then we could run the describe command. And when you run kubectl describe, you're basically telling the Kubernetes API server that you want to get detailed information about a particular resource. And you'll see I get this message saying that this CoreDNS pod is not found, and that is because I am not currently in the kubesystem namespace, so I need to specify that parameter again. And so this is going to show us all the details for CoreDNS, or at least one of the 2 pods that we are running. So if we scroll to the top here, you can see we've got the pod name. We can see the namespace the pod belongs to. And there's a lot of other properties here that tell us things like which node in our cluster this current pod with this name is currently running on. So it's been scheduled on this node right here. It's just kind of got a randomized name based on the IP address, the private IP address that it has. You can also see the labels that the pod has. You can see when the pod was actually started. You can see the annotations for the pod right here as well. You can see the overall status of the pod, which we could see when we ran the get command in addition to describe. You can see the IP address on the cluster network that the pod was assigned. And then right down here, you can see that this pod is actually being controlled by a replica set. And so it tells me the name of the replica set that this particular pod actually belongs to. And the reason that this is important is because pods can actually be spun up on a Kubernetes cluster as a standalone resource. You don't have to have a replica set in order to create a pod, but when you're creating resilient applications that automatically restart in case of failures, then you are going to at least have a replica set and possibly even a deployment controller on top of that replica set that's actually controlling the replica set itself. So when you see this controlled by property on a pod, it's basically telling you if and specifically which resource a pod is being managed by. Now, right down here under the containers section, this is what shows us the actual configuration of the containers in the CoreDNS pod. And again, we're just looking at one of the two pods that were spun up, but this pod has a single container, and that container